Hello, I'm Robert Lau from Holland. I've placed several lectures, movies on YouTube. Sometimes I place it with a little introduction with a movie or an animation on Instagram or Facebook. And one of these lectures is, well, I made two of them and a smaller afterward, and with a little subject that belongs to this presentation, this lecture. And it's all about our universe. Our universe, it starts with the little particles, atoms, matter, blocks, things. We, our car, our house, and then what bigger, something bigger, we call our Earth, and the Sun, and all the other planets around. And then we got a galaxy with a lot of stars. And then you got some groups. They seem to have a structure like soap bubble. And at the end, when we scale up, we can see our visible universe. And what is special about all these items, all this information, all the things you already know or we seem to know, we know in the outer structure, the biggest of all what we see is our universe. The smallest that we can see are particles. And for everything to see, we created more specialized equipment, and some equipment that we can see as human. It's like when we look outside from here with a telescope, we can see the sun, all the other planets, we can see galaxies, and we can see group of galaxies, and there are also maps that draw on our universe. And from here there is also biology on Earth, and we have some microscopes and we see the smallest parts and structures of life, human beings, plants, animals, bacteria, viruses, with a microscope, telescope. From here we look up there, and from here we look inside. And as humans we look also about atoms. We don't, we are about at the level to see some atoms in structures. There's a tunneling microscope. That's what we see is a little bubbly surface and structures. This is where we are. This is what we see. And beyond that, they have some beautiful thing in CERN and several other facilities to make some experiments. And with these experiments they have seen, well, some quarks and everything that belongs to that smaller, something bigger, and they have some details about what's going on the smallest what we can imagine, and that is limited for now. So we can see or calculate or estimate particles, and our universe. That's all. That's quite a lot. And we're all drawing this something like from here to there, but actually it's a particle, an atom, a planet, a solar system, a galaxy, and that is our universe. And on every place where we are, we can draw that same dimension up to the biggest that we can see. So everywhere in the universe where we are, all this is everywhere. So everything we see, we can estimate or we can feel, do some experiments for. That's all in this region. Several kinds of densities. This is total density of the universe with all these galaxies, with all these stars, with all these planets, solar, suns, planets, moons, asteroids, and so on. We got humans, we got life, we got animals, plants, and we got our beautiful Earth and all the biology and all the geology on it. And we can move on to atoms, and we can move on to quarks and protons, neutrons, and electrons, and all the other bubbling, jumping and vibrating stuff over here. This is what we know now. Many of this we've seen before, somehow in the dark sky, in the blue sky, or in the night. You can see all these things around you. It's massive. The density is enormous, and in a few hundred years we have moved our sight further on. In a few hundred years we came from here to galaxies, from galaxies to groups, and to the universe. It's only maybe 50, 60 years that we have made maps of this universe for what it is, for what it seems to be. Smaller on, we have seen many things like where we are made of, structure, bones, veins, plants, fish, genes, and so on. So we've discovered the structure of DNA, RNA, RNA, it is Dutch, English, it doesn't matter. And with all these particles, quarks, and they've got a beautiful map for the how this is rearranged about matter, all the atoms. There's a beautiful map for it, a chart, and they are all built of all the atoms, or molecules or atoms are all built up like the amount of protons, neutrons and electrons, and with a small variation on it. And all these elements are also built of smaller elements, so they come out quarks and other kinds of stuff. But one thing is that we know that, I can hold it here, all this stuff that we see, it is mass and energy. This is what we know in several appearances. There is mass and we got energy, we got movement. So everything, this is for us here to steady to the outer regions. It's a slow process for us because density is enormous, but the scale that we look up is very big. When you look up, when you're here on Earth and you see a plane, by through the sky, and you see a small trail behind, and you see it and you watch it, you can see it move. And sometimes you have to ask yourself, is he really moving? That is because of the scale that we look on. On this scale, 12 kilometers, this small plane, or maybe 100 meters in length, is going with about top speed 300 kilometers an hour, for instance. No, it's meters per second, sorry. About 300 meters per second, 240 cruise speed. But on a long distance, that we look at it, it's 12 kilometers. Then it's the distance that we see doesn't make the plane big, but also the speed slows down for us, so we can watch closely and passing by in the sky. When we look at the moon, it is 4 stages, none, half and full. When we look at the moon, you watch and you see him slightly moving. It's nearly hanging still. Our sun, in English of course. Well, I'm mostly at the end of my stories yet, so I have to buy myself some new whiteboard stift. When we look from Earth to the sun, we see him coming up in the east and going under in the west, over here on this front where we sit here in Europe. Here, there I live out. That's where I am right now. But also the sun is moving slowly. For outside, we know, of course, the sun, the earth is twisting this way on an angle, and it's twisting around, turning around the sun. Alright, it's not the point yet, but we see this slow movement from this distance, and sometimes in the night we can see, with or without a moon, we can see some other planets, the inner planets or the outer planets, and then it's a little bit, this is Mercury, Venus, here's some Earth, Mars, Jupiter, Saturn with his beautiful rings, Uranus, Neptune, and then maybe Pluto. When we look up here, we see them. And the further it is, these outer two we nearly can see with our bare eyes. We need some binoculars or a telescope. This one over here is sometimes be seen. This is mostly being seen. That these two you can see with the naked eye, and they will, even with a telescope, will not be bigger because they are not so big. Jupiter is relatively big, so with a telescope we can see it. We can see the bands over the planet. We can see it a little, and sometimes with a clear blue sky and the right equipment you can see Saturn with its rings sometimes. But it moves in several days, such a small distance, and but it's all relative to each other. So the further away, and this speed is enormous. Even our speed is enormous. But for where we look at and look around, it's relatively slow, because else you should stand still, so it's impossible to stand still. So we have a constant movement without feeling it. It's like it's just like if you are in the elevator. When you move with a constant speed up or with a constant speed down, you doesn't notice that you're just falling or you're rising. And all this thing, what we all know and what we all think about, books, lectures, what we learn, what we read. Maybe you study, maybe you're a big scientist, you're just a wanderer, or just enthusiastic about all these kind of things. So, from the smallest to the biggest that we already know, or what we can confirm somehow, there are some big parts, and I will erase it so that I have clean things to talk. And then I come to the most important part of this. Not all the details that we already know, but all the things that we seem to know or not know, because, give me a moment, I have to flatten this spoons and then I will do it. But it's an introduction of where I'm busying with nearly 20, 30, 40 years, and I've learned and read and I've watched and I heard and I read. And I've done some lectures, I've made it, and all this stuff that I learned make me look the other way and then otherwise to all this what we seems to know, or what we seems to bounded with our ideas. We have some boundaries about our thoughts. It's a clean policy. So I take you quick with a few things, and I really would like to people to learn Dutch so that you can easily watch my Dutch version of my lectures, also with some animations and other stuff. Several hours already, but I've decided to try it in English. Not my best thing, but the best part. But I do this. First thing, people say speed of light, constant. Everywhere in the universe. Light speed. Well, because several ideas that they created, we have redshift, and we got space-time, and from the smallest part up here to the universe over there in this line, they are also coming with quantum physics or quantum foam, quantum fluctuations, etc. And we got also gravity. And for all this stuff, there is something strange about it. Because when you say the diameter is this, then the surroundings is pi times the diameter. I can understand it. And when you think x, z, I, been in that kind of calculations, math, formulas, etc. So that we can measure. It's a sort of common appointment about how we do things. It's how we program our computers, our calculation programs, just like that. It's created. In these dimensions of x, z and I, they created all kinds of things. Or rectangles. And everything we do, we got beautiful math to calculate, predict, and the most unimaginable stuff that they created. And everything comes closer and closer and closer together. But I've got one question. Gravity. Massa. Partly in Dutch. Universal gravity constant times mass 1, mass 2, sorry. This is the gravitational force between Earth and the Sun. And this force, centrifugal, that is, the Earth turns around the Sun, and these two are equal. It's Earth, Sun, Earth. The speed from this Earth on this distance gives a centrifuge force. And these two, when they are in balance, the right position, they are equal to each other. So Z is Fc. And then something beautiful is happening, because somehow there is a force that this force, the centrifuge power, I can understand. Object in move will, when nobody changes the course, it will go this directly straight on. But this force, the pulling force between these two masses in this balanced distance, that's a strange force. They have made calculations, they predicted this one in combination with this, this and this, and all the planets around every solar in every solar system, the trails that they create are all predicted, and they fit in right by this formula. Even the distance and the speeds are also this, and this. There's a combination that this is always true, always. Maybe with a slight changes because the masses change of the speed or other influences from other planets or other structures in the universe. But also this one over here. This one. There are forces between this one. There are forces on this one, and between them there are also forces, and there are also forces for this. And you can tell me everything you want. You can tell me everything. You can say, well, this forces is in the last several years, many years older, are these forces between the sun and the earth. They are more and more related to effects that they ever measured about this, from a prediction from this, and from a prediction from this. And this is not so strange, but it's the same one, but space-time. E is equals mass, the speed of light, so that of course this speed of light is A is mc kwadraat. C kwadraat equals dan the velocity, the speed of light, vc, it's how you call it. But for this formula they've created some models, so this space-time disruption influence creates this downforce to that. So they're still equal, so you call it or use this kind of formula or that or this, it doesn't change. And also for these particles, this is the nuclei of an atom, this is electron. If it's a wave or a wave particle, it doesn't matter. This distance, you got this line. And kinetic energy, potential energy, and all together makes us this place in this small picture is exactly this place. And you say, yeah, this is negative forces, positive forces, pulling forces. And then is the problem to understand this, to leave it all for what it is. And then I say, okay. There is gravity, we got space-time, however we call it. Gravity is translated to space-time, so they have an explanation that it's not pulled together, but space-time is bended and therefore the planet moves over there. Well, space-time is maybe a bit, I think it's a wrong interpretation of how to explain things. And I will use color, because even though space-time, it's an imaginable explanation about how things are working. Because of this formula, EMC square. This equals sign is exactly what it is. Energy is equals the mass of something times the speed of light. Into but times something like the root, but not otherwise. But the problem is doesn't, when this is not constant, if you dare to think about it, why should the velocity of light should be constant and the same everywhere in the universe? I can't think any of my widely associated thoughts or reasons explain why this is constant. I cannot accept it. I never could. I listened, I heard, I read, I see it in equations. But what I came up with is gravity is not a pulling force between something, because when there is nothing in between, how can it pull? How can I, when I stand over here, how can I pull this camera, what's filming me, how can I pull it to me? There was nothing. When I place over here the sun and here Earth, how do they affect each other? Yeah, space-time, curvature, and this is a big curvature in that plane. That's what they display many presentations. That would be really great if this is all true. Of course, you can do the math and you can make it suitable and fit each other, so that you can translate this old formula into this space-time formula. You can do that. But still, there is a problem for me. I never said that there cannot be something just like I minus, he is plus, or we are both plus, so we move from each other, and when we're both negative, we have an attraction to each other. Well, where do we attract? Where do we extract? So there is nothing in between. And from this redshift ones and other common thoughts and common experiences and ideas about it, you've created from this redshift this map. And this redshift is also possible as blue shift. This is shifting in what is really happening in this all about us, around us, nothing especially everywhere where we are, we have this thing. And many years before they call it, before they had all the modern science equipment to prove or try to prove. This is this one. In the early years, this was the ether. In an experiment from Michelson and Morley in about 1870, they thought there is some ether that this earth is driven through or floating through, and this measurement says, that experiment says, we didn't see it, it didn't happen, so that isn't true. But you have to change your thought about it, and this is easy, because as you think, as gravity is a mass, everything, nothing is still. Stephen Hawking once placed it at the end of his books, the end of this lecture or book, what it was, he said, we can say easily that everything in the universe is vibrating, moving. Even when there is a static force, there is always a dynamic reaction or dynamic force. Everything is on the move. Everything is doing this, or everything is doing this, Everything there is a combination of this. And if the level is high or the level is low, the level is low, so the level is low, or when this is small, it speeds up in behind. Everything is on the move, nothing stands still. And therefore, I thought maybe it's gravity, not something just like this, just like there's the speed of light. I think, how can we get rid of this constant speed of light thought? And how can we get rid of this force between this one and this one? Pulls each other or driven away from each other. How can we create that? And that, they tried it to prove it with this one, but the creation was that every mass is moving through the ether. And here comes the spooky part. And I hope my black, maybe I try some blue. Gravity is actually, this blue is at its best time. I hope you can follow me because I don't. If this is a part of our universe, somewhere in the universe, and in all the processes there are, in all the movements and all the vibrations, there is created in every, between this, you got some massive energy in this, that is already explained in this formula, and we have this, we got waves, and a wave can't move through nothing. You can say it's an electromagnetic wave. Well, I got some electromagnetic waves through the quantum fluctuations, yeah, or quantum foam, yeah, space-time, yeah, but what is it? It has to be there. There has to be a platform, there has to be a medium, there has to be a duck soup pool, whatever we call it, because everywhere in the universe there is this kind of form, and as soon, and all the creation that is life, of Naya life, that everything is created, stars, planets, particles in a system, it's possible that where gravity, where a mass particle or planets created, you got an affection, and it's hard to draw, from these two together, they created this, especially when it's drawn right, you create something that somehow when this happens, when everything is steady situation, and there would be created mass, and how they do it, this is from CERN to out there in the universe, all what they have predicted. Mass is created from this all together. This mass. This is maybe one particle. This one particle is created because from this ether, from this space-time quantum foam, however you call it, this is created. Here is mass created. Mass is over there created. And when you got all these masses together, more and more and more, and they all got the same kind of spin, even with this vibration, with interacting movements in this deformed space block, this is then one particle. But when all these particles together combined to create a bigger system, like they've proved in CERN, and on and on and on the way to this, the more this process is spreading out, spreading out, spreading out by all these forces that it creates. Some like of other processes that they already know that it's happening. Imagine that this for one particle is this. So if this thousands, billions, trillions, etc. created so much mass that finally is somehow created, of course, an atom, but then there is created a sun and all these planets around it, and maybe with moons, etc. They all created. But when they are created, when mass is created, there is a balance changing of all these forces, because forces cannot turn this way, that way, and that way. All the forces have to be in one directional. So as soon as this is created, you create something like this. And that's where spin is coming from. This is what's happening. When there is movement from all this particle where the universe is made of, it all twists around on one axis. It cannot twist. When it twists this way, it cannot twist that way. You can do it, but then you change the variations of the... When it stands still, you can say X, Z and I. But as soon as it spins, there's something changing in the geometry of this. And geometry is not a solid thing. Geometry is an interaction in this, where the universe is made of. Quantum foam, fluctuation, space-time, where you can call it. And when this happens, and you can, this creates more and more and more and more, and you have some sequences where they combining. So it is, in this creation you got first this, and then you got that, and then that, and that. So you got something, just like we look at stars and Earth, our sun is here, the Goldilocks, you know all about it. But this is what here is happening. There is here an existence, there, there, and there. The scale where it can interact again, or again in another dimension, another structure, another speed, relatively speed. Room, I must watch my time. Therefore, the smallest particles have been created together, combined more and more and more and more. The formation of our ether, of our universe, plays everywhere. So, indeed, for the sun, you got an influence of space-time, or space. And you got for the sun, earth, planets, particles, atoms, everything together creates this deformation of a local piece of our universe. And this is smaller. This phenomenon is as small as what they all do in experiment about in CERN and other great experiment stuff. So gravity is not something like 1 million kilos or 1 trillion kilos. No, gravity is a combination of that beautiful, this one, gravitational constant for the mass. It doesn't matter what kind of mass it is, but this number is created, is actually created by this force over here. Because nothing stands still in the universe. The universe, the ether, everything is around it. And therefore, because it's the influence of this local ether is influenced by particles, is influenced by upgrowing particles till they become a sun or a planet or atoms. In other, this one creates atoms, actually from particles created atoms. And when you got more and more and more combined, because the mass, the destruction, the destruction of this local it's not an extraction, but it is an inhalation, sort of inflation, is coming from this process. And it's every process that will be, if I can write it what it's in blue, is from this. When you got here some attraction, we call this G, we call this G. I have to use the red one, I'm sorry. I must buy myself some new things. This is G, and otherwise there is always a counter influence from this. When you do this, when you take, you absorb this twisting energy, this twist, this turning, this spin, you always created something backwards. Always. There's always a leveling out. A wave. This is positive, negative, and when we are here, there is not none. There is another. I'm so sorry about this script. I must definitely buy a new one. This is vertical, and this is horizontal. And this moves in this direction, and this one. So this one is vertical, yes. This is the wave, plus, minus, and in between, this is where we see it's a particle. That's called a photon. So in this process, when there is a distortion from any kind of changing of moving from electrons, shifting from one to the other boundary, they create in this system, where it's there where it's possible to change from this small piece to the other one, it will be have a distortion of this local space-time dot about the size of a particle. And so a photon can't travel. Light can't travel, like if this is light, I can send it over there, but this is not light. Light is just a distortion plus minus, but also in the other direction. So you can call it that a wave. The wave is actually, the dynamic and static forces disruption. This is called the electromagnetic wave. But a photon is also created on this place. So it's wave particle. Wave particle is actually a, I call it in English, they call it a duality, but it is a connection. It's when it's a wave, and here the movement is not nil. So this is where we see a photon, because they got an interaction in this part. So this wave which is got, because it's got a dynamic force, it's hit by another force, so it creates a force, and this goes on. But the speed from this process is depending from this part of this little universe, of the smallest part as we can imagine, on a level as this. So therefore you don't need photons to travel through space, because it would be enormous, and it costs enormous energy to travel. Well, light doesn't cost anything actually. A wave particle duality is actually a wave particle connection. And in this connection, and I've got 2 minutes about, okay. So the disruption of this process, what I here created, measured, happens over here. And this all together creates together in all these special the special marks, the special related, because this is, we do this in a math graphite, and they have all some predictions where all these several difficult particles that happened over here in this principle over here, and also for this, where in what place from over here to there is this. This is particle, molecules, planets. This is maybe the universe. And when we will be later on, many years from now, we probably will find that this is never ending. We still look at a smaller part, and a smaller part, and a smaller part. And when we look outside, we look at a bigger part, a bigger part, a bigger part. So gravity is not just something, a pull force. Gravity is created by the influence of this particle creation from the universe, with all these processes that are here tested over here. And light doesn't need, it is not an own identity, it's not an own entity, it's just a wave movement in this interaction, So it travels with the speed of this process. The process of a universe is this. Only D is not affected by space-time, because when you create that formula, this beautiful formula, that's space-time distortion or dilatation between two time moments, it is that this is over here. Just the distortion of the mass here, it means that relativity is this. My last trip is over here. So the speed of light here is for the sun, otherwise than the speed locally by Earth or other planets. And when you change the formula without this, and you said the speed of light is just locally where it's in this force, in space, in our universe, on this scale, or here, or here, or here, or here. And we will probably go on till our borders will be reached. There will never be a starting point of our universe. There is nothing like matter that you can buy in the market. And there will be no end of our traveling to our beautiful universe. There is no end, there is no beginning, there is not light that's bounded by its own velocity. It's not an entity of its own. Light is just a static dynamic wave in our little particle universe, space. And maybe we can give either his name back to where it really belongs, because a failed experiment doesn't prove that this is not existing. It is the wrong interpretation of what's really happening. So if we accept that there's ether, there is space, just like it's like water or some soap or however you can name it, or quantum foam fluctuations, because that is what they have seen of estimated with experiments. But with ether, space, there is, of course we can say it's gravity, but it's not gravity, it's traction, an attraction force between these two, and it's created by the twist, the inertia moment by this process in this local where universe is made of. Our universe is made of this kind of stuff. On the smallest part is over this. And therefore, this creates so much inertia movement that this is creating the enormous attraction of the sun, but also on this mass, and also on an atom and on particles and everything in our universe that's already there, that we can see, that we know of. So, in my opinion, we don't need gravity as a pulling force. There is no pulling force between everything. When I hold this and then I have to stop because I have to go, they will not even bloom. This is positive, negative. Well, nothing can combine them together. No one can do that. But if they are part of a system that this is all the same in this system, they twist. Eventually, that they have combined the same twist, and probably they will so, and then they will be bind together in this principle over here. So then gravity is actually an inertia force variance. And on a planet, when you got, maybe you can see it when we have a planet, you also got north and south. But there is no north-south. This is left, and the other one is also in the upper. Also left. Therefore, when you in this combined enormous amount of mass of particles created in this Earth, you got an inertia. There's some sort of affection on this outer center, on another scale from the forces of our universe. This is a twist. Twist is the same. Therefore, when they combine with other lines, when they have also the same direction, so this is not north-south, this is upper left turn, and this is down left turning. So when they spin clockwise, different wise, they will not combine unless they will change, so that they will fall in the same twisting energy of this local place on our so-called gravity. And redshift created this. Redshift made it. Redshift is also based on a common good thought of that light, speed of light is constant. But in this, well, in my opinion, when speed of light is depending on where it is in this local created distortion field called gravity, or universe, the smallest particles, there is speed of light different. And therefore, the universe don't have to be expanding, because when the universe expands, they say at the outer region of our universe, the speed of light is going so fast, it's going past the speed of light. They say that it's impossible. Why should it? And where should it be nil? Also not impossible. And even a black hole, even that is all changing the rules of this system from all these combined things that there have to be part of matter. This is all created by the speed of light locally where the wave is moving. Here it moves other than over here. And our universe don't have to be just like a simple, constant, never-ending, or dissolving, or big crunch, or big dissolver. The process is still that there is, of course there is, we got this behavior in the universe and we got this behavior. This is gravity and this is expanding. But it's not the end of our universe. It's not constant light. So this is the end of my speed Dutch lecture about our universe. I dare to say the speed of light is not constant. It's how do you call it? It depends where the wave is created in our universe, on what place. Near mass, the black hole, the planet, or in between particles like protons, neutrons, and everything. Therefore, our universe is made of either space, and not space-time. Space-time is the common good for this one. So, I hope someone will ever understand me what I'm saying. But in my Dutch lecture I go beyond this and much further. So, thank you for watching and listening, and maybe till next time. And now I have to stop my movie because it's time to go.